So in this lesson, what we're talking about is something called chain rule. And chain rule is a technique for finding derivatives of composite functions. So the only time you're going to use the chain rule is whenever you have a function that's been embedded inside another function. So for example, if we take something like c of x equals f of g of x, so using c for chain, it's kind of a silly thing, but c of x equals f of g of x. So you can see that g has been embedded inside of f. Or maybe we take another function and we'll just call it f. So f of x equals the quadratic x squared plus 2x minus 1. That's been embedded inside something to the 3/2 power. Or maybe we have something like g of x where the function 3x squared has been embedded inside the sine function, or something like h of x equals cosine squared of x, where the function cosine has been embedded inside of something squared. So those are all examples of when you're going to use the chain rule. So what does the chain rule actually say? So let's take our arbitrary function c of x equals f of g of x. The way that we're going to find the derivative of this, we label c prime of x as the derivative, and that's equal to f prime of g of x, and then we're going to multiply by the derivative g prime of x. So essentially what we're doing is we need to identify the inner and outer function. So in this case, f is on the outside, g is on the inside. I'm going to take the derivative of the outer function. I'm going to repeat the inner function exactly like it's stated, and then multiply by the derivative of the inner function. So let's look at a few examples. So if I have f of x equals square root of 1 minus x squared, let's first rewrite this as f of x equals 1 minus x squared to the 1/2 power. So whenever I go to find the derivative f prime of x, I'm going to take the derivative of the outer function, which is 1/2, and then I'm going to subtract 1 from my exponent. That would be our power rule. So I'm going to bring the 1/2 down, subtract 1 from 1/2 to get negative 1/2. I'm going to repeat the inside exactly like it's stated, so 1 minus x squared, and then I'm going to multiply by the derivative of what's on the inside of my function. So the derivative of 1 minus x squared is negative 2x. And that's my derivative using chain rule. I can definitely simplify if I wanted to, but we'll leave it here for right now. On this side, I have g of x equals 1 over x cubed minus 5x quantity squared. So I could rewrite this as x cubed minus 5x to the negative second power. So I'm bringing my exponent in the denominator up to the top, but I'm representing it as a negative. When I go to find the derivative, g prime of x equals, I take the derivative of the outside, so negative 2, subtract 1 from the exponent, repeat the inside exactly like it is, and then I'm going to multiply by the derivative of the inside. So x cubed minus 5x is 3x squared minus 5, and that's using power rule. So the derivative here, g prime of x, equals negative 2 times the quantity x cubed minus 5x to the negative third power, and then multiplied by 3x squared minus 5. Let's look at two more difficult examples. These are going to involve trig functions. So if you haven't learned your trig derivatives yet, you can skip this for right now and come back to it later. But these are examples using trig functions. So if I want to find the derivative h prime of x, I need to identify my inner and outer function. My outer function here is sine x. My inner function is 2x. So I take the derivative of the outside. So the derivative of sine is cosine. I'm going to repeat the inside and then multiply by the derivative of what's inside. So I end up with cosine of 2x multiplied by 2, and I can simplify this as 2 cosine of 2x. For my other function over here, f of x equals cosine squared of x, let's first rewrite this as cosine of x quantity squared. So the notation for trig functions is to write the power after the trig function, leaving the argument by itself, but we can rewrite this as a quantity if need be. So taking the derivative here, I identify my outer function as something squared. So I bring the 2 down, and then I'm going to subtract 1 from the exponent, which is just 1. I repeat the inside, which is cosine of x, and then I'm going to multiply by the derivative of the inside. So the derivative of cosine x is negative sine x. So simplifying this, I can say f prime of x equals negative 2 cosine x times sine x. And that's it.